Welcome to Lesson 4 of Module 3, where we'll be exploring AI agents. Today, we will review Lesson 3. Then, we will discuss tools and agents. We will cover some specifics of LangChain agents, and then we will dive into the agentic workflow. Let's recall, from the previous lesson, RAG architecture, a powerful approach that enhances AI responses by combining retrieval with generation. The key advantage of RAG is its ability to ground responses in factual retrieved information rather than relying solely on the model's training data. Each component builds upon the previous one, creating a seamless flow from user query to final response. The example shown demonstrates a practical application using Amazon's return policy, but you can adapt this to any domain-specific use case. We now turn our attention to tools and agents, which represent the next evolution in AI assistance systems. Today we're addressing crucial questions about expanding LLM capabilities beyond traditional language processing. The key focus is on three main areas. First, how we can extend LLM functionality beyond pure language generation. Second, implementing mathematical operations and database queries through LLMs. And third, the potential for system integration to enhance overall capabilities. These questions are fundamental to developing more versatile and powerful AI systems that can handle complex, multifaceted tasks. In our journey towards more sophisticated AI systems, we've seen an evolution from simple prompting to chains, and now towards agents. While prompting gives us single-step inference capabilities, and chains provide structured sequences of predictions, agents represent a significant leap forward. They can automatically determine what actions to take and leverage large language models as their reasoning engines. This progression shows how we're moving from rigid, predefined approaches to more flexible and autonomous systems that can better adapt to complex tasks and situations. The key difference with agents is their ability to make independent decisions about the next steps rather than following predetermined paths. Now we're discussing AI agents, which represent a significant advancement in artificial intelligence technology. These agents are essentially AI systems that can independently determine the best approach to solving tasks that users present to them. What makes them particularly powerful is their foundation in large language models, or LMs, combined with specialized tools that enhance their capabilities. Think of LMs as the brain and the tools as additional skills they can leverage. One of the most exciting aspects of agents is how they're revolutionizing AI development. They're dramatically speeding up both the development process and the practical application of generative AI technologies. This means faster deployment and more efficient implementation of AI solutions in real-world scenarios. Tools are essentially functions or interfaces that the agent can interact with to accomplish tasks. These can take various forms including APIs, document loaders, functions, or even other agents working in tandem. Think of them as the Swiss Army knife for AI agents. Each tool serves a specific purpose. Tools can be both simple and complex, from basic calculators to sophisticated knowledge retrieval systems. Not all tools require an LLM to function, which makes them versatile and resource efficient when appropriate. Examples of tools include a knowledge base containing company documents, or RAG, a calculator or math tool, an API call to retrieve weather information, and a Wikipedia tool to search for facts. What can agents do? First, they can understand natural language requests using LLMs, making them highly accessible to users. Then, they generate well-thought-out plans using sophisticated prompting techniques. The identification phase is crucial. Agents can determine exactly what resources they'll need for the task. In the execution phase, they put everything into action, and importantly, they're resilient and capable of overcoming obstacles through retry mechanisms. This creates a robust system that can handle real-world challenges effectively. We'll now examine a powerful framework called REACT, which stands for Reason and Act, leveraging two fundamental capabilities of large language models. LLMs have demonstrated impressive reasoning abilities, allowing them to think logically through problems. These models can generate action plans to accomplish specific tasks. The innovation of REACT comes from combining these two capabilities into a cohesive system. The reasoning component is responsible for creating, tracking, and updating action plans, as well as handling errors that might arise during execution. Meanwhile, the acting component interfaces with external functions, tools, knowledge bases, or environments to implement those plans. There are two main categories of agentic tasks. The first is knowledge-intensive tasks. While simple prompting can lead to fact hallucination, we've made significant progress through agents that can autonomously work with data sources. This represents a major step forward for accuracy and reliability. Moving to decision-making tasks, we've seen impressive improvements through custom tools and enhanced LLM planning capabilities. However, we must remain realistic about current limitations. The gap between AI performance and expert human decision-making is still substantial, which presents both challenges and opportunities for future development. In this section, we'll explore LangChain agents, which represent an important framework for implementing agentic systems in practice. Let's discuss LangChain tools. These tools serve as the building blocks for agent interactions, whether through APIs, functions, or other mechanisms. A key point to remember is that while some tools are LLM-dependent, others can operate independently. The math tool example demonstrates how LLMs can enhance tool functionality when needed. Finally, the code snippet illustrates the straightforward process of implementing these tools, showcasing LangChain's commitment to easy integration with third-party services. The power of LangChain lies in its adaptability to various use cases and requirements. Now, we'll be discussing LangChain toolkits, which are essential components that streamline various development and integration processes. These toolkits are pre-configured to save you time and maintain consistency in your implementations. Whether you're working with GitHub repositories, handling JSON data, or managing Power BI datasets, these toolkits provide the necessary functionality right out of the box. Each toolkit is specialized for its specific use case, making it easier to integrate different services and platforms into your workflow. Understanding these toolkits is crucial for maximizing efficiency in your development process and maintaining robust integrations across different platforms. Now we're discussing LangChain agents, which are key components in autonomous AI systems. Think of agents as decision makers with the ability to act. Just like how a human worker needs to understand their tools, our agents need clear descriptions of their available tools to function effectively. A crucial point to emphasize is tool selection. You wouldn't give a carpenter a paintbrush to build a cabinet, right? Similarly, we need to be strategic about which tools we give our agents. The agent runtime, particularly the agent executor, acts like an operating system for our agents. It's the environment that makes everything work together smoothly. Remember, the success of an agent often depends on how well we set up these three elements: clear decision-making capabilities, appropriate tools, and a well-configured runtime environment. Now, we'll explore the key limitations of AI agents that developers and organizations need to consider. The first major challenge is the requirement for complex models. You can't simply use basic LLMs and expect optimal performance. This leads to higher costs and resource requirements. We also face significant challenges with abstraction levels. While abstraction can be helpful, it makes troubleshooting and debugging much more difficult. Think of it like trying to fix a car engine when you can't see all the moving parts. Security is another crucial concern. Our agents can be vulnerable to adversarial examples, which could potentially compromise system security. This is particularly important in production environments. Finally, there's the irony that agents might actually overcomplicate simple tasks. Sometimes a straightforward solution is better than an agent-based approach. Now that we've examined LangChain agents, let's explore how agentic workflows function in practice. An agentic workflow represents the structured process through which AI agents operate to accomplish tasks. Consider an example question and answering task where the question is, what is the age of the current U.S. president today? This requires several sequential reasoning steps. To do this, an LLM would need to determine today's date, then identify who currently holds the presidential office, find their birth date, calculate the difference between today and their birth date, convert that calculation into years, months, and days, and finally construct a coherent response. How would a traditional LLM solve this? Without agents, the typical LLM answers to this question would be inaccurate and not useful. They will respond, but be unable to find the answer. This is precisely why we need to consider different approaches and potentially look at agent-based solutions for more accurate and real-time responses. Now let's examine how agents can solve the limitations we just discussed. With agents, we can implement something like the REACT technique, which fundamentally changes how language models approach dynamic problems. When using agents, the process begins with automatic generation of a plan to address the query. This is followed by a methodical, step-by-step execution of that plan, allowing the model to work through complex problems systematically. The key advantage here is that the model can provide accurate answers to time-sensitive questions every day without requiring any additional code, training, or deployment changes. This is particularly important for queries that reference today's date or other time-dependent information. In this section, we'll explore how AI agents can leverage various tools to enhance their capabilities. As shown in this diagram, agents can access a toolkit that includes Wikipedia, web search, date functions, calculator, and Python interpreter tools. When an agent receives a query like, "What is the age of the current U.S. president today?" it doesn't simply rely on its pre-trained knowledge, which might be outdated. Instead, it follows a systematic process. First, it analyzes the question and determines which tool would be most appropriate to answer it accurately. The Search and Select tool component acts as a decision-making mechanism that helps the agent choose the best tool for the task. The first step in calculating someone's age is to establish today's date as our reference point. Notice how the central component has changed from a general search and select tool to specifically date search, showing the agent's focused approach to solving the problem. The date tool is now highlighted in pink, indicating it's the active tool being used at this stage. You can see the agent's thought process visualized through the thought bubble containing "today is." This represents the first logical step in our calculation. This step-by-step approach demonstrates how AI agents don't just jump to conclusions, but rather break down complex questions into manageable components. In this case, before we can calculate the president's age, we need two pieces of information: today's date and their birth date. We're seeing the agent tackle the first of these requirements. The other tools remain available but inactive at this stage, as they'll be needed for subsequent steps in the problem-solving process. This methodical approach supports accuracy and reliability in the agent's response. Moving to our third slide, we can see the agent progressing to the next logical step in solving our question. Having established today's date, the agent now needs to identify who the current U.S. president is. Notice how the web search tool is now highlighted in pink, indicating it's the active tool for this stage. The agent's thought process, shown in the bubble, has evolved from determining the date to identifying the current president. This is a crucial intermediate step. We need to know who the president is before we can find their birth date. The web tool has been selected as the most appropriate tool for this task, as it can provide the most up-to-date information about the current presidency. This sequential approach continues to demonstrate how AI agents break down complex queries into manageable steps, upholding accuracy in the final response. The other tools remain available but inactive, waiting for potential use in subsequent steps of the problem-solving process. In this fourth slide, we see the agent moving to the next logical step in our age calculation process. Having identified the current president through the web search tool, the agent now turns to Wikipedia as a reliable source for biographical information, specifically the president's birth date. Notice how the Wikipedia tool is now highlighted in pink, indicating it's the active tool. This is a strategic choice. While the web search tool was best for confirming current information, Wikipedia is ideal for established biographical data like birth dates. The agent's thought bubble shows it's specifically seeking birth date information, which is the last piece of data needed before we can calculate the age. This demonstrates the agent's ability to not only select the appropriate tool for each task, but also to build upon previously gathered information in a logical sequence. We're now just one step away from having all the necessary data points for our age calculation. In this fifth slide, we see the agent entering the final computational phase of our question. Having gathered all necessary data, today's date and the president's birth date, the agent is now preparing to calculate the exact age. Notice how the calculator tool is highlighted in pink, indicating it's now the active tool for this phase. The thought bubble shows the agent is preparing to perform a detailed calculation, not just in years, but including months and days for precise accuracy. This level of detail demonstrates how AI agents can provide comprehensive answers that go beyond simple calculations. The final slide demonstrates how the agent synthesizes all the collected data into a formatted response with specific year, month, and day values for the president's current age. As we wrap up our exploration of agents, we've covered fundamental concepts about how AI agents operate, make decisions, and utilize various tools to solve complex problems. In the next lesson, you will learn about multimodal applications. Thank you for watching.